And looks like we're recording. All right. So thanks again, guys. Welcome back. If you've been to these calls before and you're back, glad to have you. Welcome if this is your first time. Hopefully this short briefing is something you'll find worthwhile and valuable, and you'll keep coming back for more as we focus on various topics in our intelligent edge area of expertise and area of focus. So I'm Kevin Sullivan. I'm a Azure Intelligent Edge Global Black Belt on the Microsoft side. So my team focuses on what we term as intelligent edge and what we define as some of the intelligent edge solutions that we offer when it comes to both from compute as well as an Azure platform perspective, things that we can do to provide you the great things that Azure can provide you, but maybe perhaps not exactly within a public Azure region. So the agenda for these calls is relatively simple. So I'll spend a couple of slides here on just an overview and maybe some late breaking news in the area that we focus on at Azure Intelligent Edge. Also, just for the newcomers, just touch off real quickly on what this call is about and what we typically end up concentrating on or focus on in these calls. The main topic is essentially I kind of pick a focus area of the session or the call. And so we typically will have one of those each call, spend the bulk of that call talking about that. And this week, or this session, I will be going over Azure DataBox Edge. And from a simple walkthrough perspective, if you were on a call, probably going on, it was sometime in August, I actually did have a call with one of our cloud solution architects here on the Microsoft side that I had the privilege of working with at one of our manufacturing customers. And we delivered a successful POC, which is we're now turning into a pilot based on the Azure DataBox Edge. And that call is recorded, and there's a lot of good information about what we did in that. But that was, in my estimation, was a little bit jumping ahead because we didn't really spend a whole lot of time on DataBox Edge as far as, what is this thing, kind of step back and take a look at what is it used for and what's its architecture look like, and then give maybe a more simpler or a more basic walkthrough of what it would look like and what it would be like to manage it. So what I'm going to do in this call for the focus area today is to walk through that in the bulk of this call. And then of course, Q&A. So any questions that come up, this call is typically, we get about anywhere from 20, maybe upwards of 50 folks, and that's typically pretty manageable. So if you want to IM your call or message your call through Teams, that's great. And if you basically all have audio access, we can do that too. Just let me know. I'll try to field those questions, and we've got other folks on the line, including a couple of people from my immediate team, as well as other Microsoft internal and even some partners and customers that might answer questions. Feel free to do so using Teams. So just a little bit of brief of what this is. So this is a 30-minute briefing. I open this up to everyone. So anybody and everyone that's interested in the intelligent edge space and what we're doing and specific topics that we have from every other week to every other week is welcome to come and join. Because of the open format, we cannot really share any NDA information. So those of you that work closely with Microsoft that have NDA contracts with us, know kind of the drill on this. There are some roadmap of items we can talk about, and there are some that we can't. So we want to make sure that you guys are aware of that. We're not trying to be rude if we have to defer or not answer a specific question, but we just can't simply in this format. We are using Teams. It is open in that it essentially allows us to provide an easy get in and start going, but it also can be bad in the sense that everybody has equal partnership to make noise and take over slides and screen sharing from whoever's presenting, which can be a bad thing. So far, so good. We haven't had any of those such issues. If we move to a bigger set of folks, we might move to a different format, but for now, Teams is working great. But again, feel free for the Q&A and for the discussion. It's open to all. And all calls will be recorded and posted here. You may have seen these links. I've got a handful of AKAMF links. This one at AIEB-channel. We'll send you to a YouTube channel that I've set up where I've dumped or continue to dump the recordings of these calls. All right. So let me go ahead and get started. Some quick news. So if you're on the last call 2 weeks ago, I had this call, or rather I had this announcement. It actually was available, then it wasn't, and now it's back again. So it's there for real. I do have customers, and I know of some internal sites that have Azure Stack stamped that are being deployed on 1908 as we speak. So the update is now available and for real this time. So again, there's the link there. Probably just easier just to do a search for the update, and you'll find it for those people that have Azure Stacks that they wish to update. The update is a pretty significant one because we do move. We do have a major reimage that will happen on the nodes of that stamp because we are moving forward to a major revision of the Windows operating system underneath on the stacks themselves. And so there also is a prerequisite that the update will not allow you to update unless it's been achieved, which is the mentioned hotfix as well as the OEM version, depending on your OEM, whether it's HPE, Dell, Cisco, et cetera, needs to be taken care of before you can continue. And the links are there to explain that and how to go about those per the OEMs you've got. All right. So again, just a very high level, what we focus on in this call, from a Microsoft perspective, there are several things we could talk about from an edge perspective, from everything from talking about Azure Sphere and what we're doing on that space specifically to specific IoT devices, maybe even HoloLens and drones, et cetera, et cetera. On this call, we tend to concentrate kind of on this middle area here. What I mean by that is technologies and solutions that are enabled by really two big things right now in our edge portfolio, and that's Azure DataBox Edge and Azure Stack. So if you look at it across a taxonomy, if you will, of what Microsoft is doing in the space of edge, from everything from the microcontroller all the way up to our Azure public regions, my team and the focus of these specific calls focuses in on the purple section. So essentially, think of it as kind of the middle area of integrating the platform, the goal from an Azure perspective. So really, it's more about providing what Azure can provide and the value Azure can provide from a compute platform, not just in a public region or one of our sovereign regions to GovCloud, but also where it may be needed to go. So in the case of certain scenarios where the laws of physics dictate that I can't go to public cloud and therefore can't make use of Azure, or I've got laws of country that don't allow that. I need to provide and would like to provide modern cloud things within a certain geography or a certain site or location. We have an integrated platform story to tell, and the two things in our portfolio that are major focus areas in that are the Azure Stack platform and the Azure DataBox Edge platform. And so today, what I want to focus the call on is Azure DataBox Edge specifically. And so again, I want to give a more, I don't want to really call it simple, but again, just to give you an overview of, for those that have maybe heard about DataBox Edge, but really haven't gotten around to really exploring, well, why would I even look at this thing, right? So let's start with the basics of what it is. And then I'm going to give you a demonstration of what it, just give you a simple walkthrough of what it would look like if you were to adopt DataBox Edge to tackle one of the use cases that we're seeing or that are trending from that perspective. I'm going to have to go through, there's somebody with the mute on. I'm going to mute. I'm getting a lot of feedback, and I don't know, I think that's coming from me. Philip, I muted you if you're curious, so that helped me a little bit. Okay, so Azure DataBox Edge, in a nutshell, is a piece of hardware. It's a piece of hardware which you deploy just like you would really any other server. It's a 1U node rack system. It consists of 20 cores. It actually has an FPGA in it, which we'll talk about here in a second. But it essentially is a physical piece of hardware. There are 4 things that are important to know at a high level about what Azure DataBox Edge provides you. And so on the right-hand side, you can see those 4 things, starting with this ability to do data movement or data transport. So you may be aware that this isn't anything new. We've had an Azure import-export service for many years in Azure. So again, it's all about, hey, I need a bulk upload, or I've got a bunch of data sitting in my on-prem environment, and I would like to get it, and I want to get it there efficiently over to Azure so I can migrate or build modern cloud services around that data. Well, so how do I do it? Well, I can transfer it over the wire, but sometimes that's not feasible or the most efficient way, depending on the location. And so we have an Azure DataBox family that can give you things like ordering up Azure DataBox disks of various sizes and form factors to allow you to bulk import those or copy your data to those disks, then offline ship those, and then we import them into the Azure public region of your choice. We then introduced, about the same time we introduced this DataBox Edge, this virtual appliance called the Storage Gateway. And the Network Storage Gateway is essentially an Azure DataBox, but essentially is on the wire. So essentially, like a DataBox, I can carve SMB or NFS shares on it. I can drop my data to that Azure DataBox Gateway. But instead of you having to offline ship that up to Azure or to an Azure region and have it imported, it can upstream that data or upload that data on your schedule using your bandwidth over a period of time. So it essentially would be something that would sit in your environment, virtual appliance, and basically transport data over. DataBox Edge has that ability, and that will become important given the primary use cases we're seeing or we're intending DataBox Edge to solve. That is an ability to just handle all of the, let's just call it the messiness or the complexities of getting data from, or meaningful data or data that I want to go from my edge location or my on-premises site towards Azure public cloud. Essentially, it handles that for you in a nice way where you don't have to write scripts or code and get into or have to do that manually to get into the complexity of that. So that's number 1. The second thing it does, and this is where the DataBox Edge platform, this device that you can get from us, sets itself away from the DataBox family, because nothing in the DataBox family, the DataBox Gateway virtual appliance or the DataBox disk that you can order up to just, stick data on and ship them away, none of those things have the ability, and that is the ability to do edge compute. So edge compute is in the form of being able to take a DataBox Edge, once you deploy it to a network, to allow it to run containerized compute and be managed, or therefore deploy and manage the compute on the DataBox Edge through our IoT Edge and IoT Hub service in Azure. So essentially, it gives you the ability to take today Linux containers and deploy those to the DataBox Edge and run those obviously wherever that DataBox Edge is deployed, on-prem, on-site, the edge location that you have. And so there's a couple of things that are nice about this. So instead of just transferring all my data up to Azure, that might not be what I want to do. There might be maybe the data that I'm getting is being collected from sensor data. And before I want to do that, I at least want to pre-process or filter that data and only be left with the data that is meaningful for me. Or I have to transfer the data maybe because of privacy concerns or laws or regulation before I send it to a public cloud. That compute feature would allow you to do that. In combination with that, we provide a Project Brainwave FPGA, and that is specifically for scenarios where that pre-processing of that data is Azure machine learning available, right? So if the data, and what we're seeing is in a lot of machine learning inferencing scenarios is, hey, I can ship all my, if I can get all my data to Azure, that's great because I can do all this stuff up in Azure. I can use FPGAs in Azure. I can use just regular core. I can use GPUs in Azure. But again, That's great if it's in Azure. That might not be a thing I can do because of physics, right? Latency is too horrible. I've got too much of this data. And again, I would rather like to have a platform to have a way to control it from the cloud, but essentially have it down in an on-premises or an edge location that makes most sense to basically do my inferencing of this data. And so the DataBox Edge can do that, and we can do that if you have models that take advantage of the FPGA, can essentially be done on that DataBox Edge device. And the final thing is that it's cloud managed. And so this is kind of a transactional thing. It's not really a technical value, but it certainly is a very powerful value from just, how do I acquire a DataBox Edge and how do I manage and care and feed the edge? Unlike a traditional piece of hardware that I would deploy in my data center, where I would have to acquire that, perhaps have a big capital expense for that data, and then over time, it's up to me, right? What am I going to run on it? Is it going to be a VMware host? Is it going to be, what is this thing? The Azure DataBox Edge is more of an appliance, right? So all the updating and patching and its control is in your hands, but it's done through the control plane that is Azure. So that's number one. And the other thing is from the perspective of paying for how I consume Azure DataBox Edge, it's as close as it can get to consuming really anything in Azure that we have. So in Azure, we have the ability to spin up, spin down VMs and databases and storage, however we wish, and we essentially just pay per on a consumption basis. So as you operate that data or those things, those resources, we will get charged accordingly. DataBox Edge is that way too. I sign up through Azure, the box ships down to me, and then once we confirm payment, or I'm sorry, the shipment has arrived, and we essentially will bill you a set rate per month for that DataBox Edge or DataBox Edges that you have deployed from your Azure subscription. Once you're done with the DataBox Edge, you essentially shut it down, you ship it back to us, and we stop billing you, just very much like we do things in the cloud. So it gives you a nice operational aspect, an easy way to not only just manage it from a management perspective, but also from an acquire perspective. DataBox Edge equals Azure. So if you're already doing things in Azure and you're already consuming Azure, using Azure consumption as something that's already a thing in your enterprise, DataBox Edge just becomes another piece of that, not something extra or different. All right, so the use cases. So what we're finding mostly, so again, that DataBox Gateway feature is just part of DataBox Edge. And so, yes, you could use the DataBox Edge just to transfer data from the edge to the cloud. I can carve up any number of SMB shares or NFS shares, and then I can decide to plumb those to an Azure storage account. And then I can then throttle and schedule when and where I want that data to be sent. But I also can do data pre-processing at the edge as well, as we discussed, in data pre-processing / machine learning, because we're seeing a trend that seems to be the primary case for the edge device, and a very powerful one, given that we can manage it from Azure and do it operational like we do most things from a cloud perspective. And so from that perspective, I'll skip ahead to this. So if you were on the call in August, we had talked about a factory setting where we took a DataBox Edge, we put it in their factory, and then we set a couple of we trained very quickly a couple of models to do some safety violation issues for people working inside certain areas of the factory, as well as some quality assurance issues around products not being handled in the proper way, those types of things. And so we have other things too. There's a great case study done by Olympus and our partner Mill5 using DataBox Edge in a patient doctor operating room setting to essentially become more proactive about, and more efficient about, is the operating room ready? Is it not ready? Those types of things running at the edge, as well as retail, grocery chains looking at void detection. And I even have another major grocer or retailer that's looking at, let's try to minimize or prevent fraud, such as, barcode switching, those types of things. So basically, if we can strategically place cameras in certain areas, we have a model that's good enough to figure this stuff out and what it's happening, wouldn't that be great? The one thing all of these things have in common is that a lot of it requires a ton of data, video stream, high quality video coming from somewhere in that environment, and then having to have the ability to quickly get it somewhere where I can analyze it, and then having something, the power of a lot of cores and maybe an FPGA to actually do the inferencing. And that's what DataBox Edge gives you. And so as the slide says, what do we have in common between a retailer trying to do void detection, or doctors trying to figure out the operating room is ready and the patient's there, et cetera? There really is no difference, because it's, hey, I have to capture some data, typically some video, some stream of video. I have to analyze the data. Now, what will diverge there is, what model are you going to what are we looking for? Is it object detection? Are we looking for or not looking for certain things? That's different, but essentially the same architecture is in play and across all of these uses, what we're finding as we look. And then on the back end of this, we can do custom logic around, hey, we can provide alerting in our when we talked, I think we brought this up, but at the manufacturer we did a POC on, we actually did an inferencing model where we took a simple logic app and a simple Power BI. It was very easy to plumb up. Hey, let's immediately show a graph of what we're finding. And the nice thing is yes, there's a ton of data on there, but essentially we're using DataBox Edge just to give us the interesting things. What are the violations? Which is, represents probably a fraction of a percent of all of that data having to go to the cloud to do that analysis. And so across all of, industry, we're seeing this. And again, there's commonalities. There's different use cases, but I would argue that, from an inferencing perspective, they're pretty similar and exactly similar from how you would use the DataBox Edge. It's just using it for different purposes and inferencing models across retail, manufacturing, energy, et cetera. And so what I'll do now is give you a little bit of a demonstration. And this is something we didn't do in the talk we had in August, because we wanted to focus more on what we delivered and what were the results. And that's all good information. There's some best practices in there about how you would go about building a model that, object detection, those types of things. But here, I just want to give you a very quick look at, so I've got Azure and I want to get a DataBox Edge and I want to use it for a simple inferencing case. And so what you're looking at here is I've got a DataBox Edge in my Azure subscription. And how I got here was really pretty simple. You essentially, like anything else in Azure, it starts with, hey, I create a resource group and I add a resource. In this case, I'm adding a DataBox Edge. Now, what's going to happen if I click through this is there's going to be, hey, this is a physical device. So then it's going to go through and ask me some questions about if it's a DataBox Edge, I got to physically ship the device, which takes 10 days or so to get there. But essentially, it becomes a thing. It becomes a resource within Azure in which I can control and manage. And so back here, if I go back to my resource group, I already have this. I already have a DataBox Edge. I've requested it. I've got it deployed in one of our MTCs. This one close to me because it's here in St. Louis. And so this DataBox Edge is sitting in a rack, sitting in my St. Louis site. As you can see, it's got, it's online. It's got about 12 terabyte capacity, NVMe storage on it. I've carved up a few shares for that data movement, so that gateway movement. And I've also lit up compute on here. And the reason I know that is because if I look at what modules are running on my MTC DataBox Edge, you'll see that I've got several modules here. The two that are for this demonstration are this video inferencing container module and this ResNet module. So this video inferencing container essentially is coded to very simple a container that says, hey, if you find a video file or a picture or something, if you land it into this share, so I have kind of an input-output share here. So if you land something into this local share, I'm going to then, that's going to trigger, because DataBox Edge also has the ability to streamline and make things easy, I can do a file trigger to basically say, hey, when this file trigger triggers, the video inferencing is going to then take a look at what's in that share and start inferring or start processing that data by passing it over to this machine model or this machine Azure ML container, which is essentially going to score it trained at what it's going to be looking for. Now, in this case, what it's looking for in this case is cars. And so just to, again, this is a fairly basic model, but just to kind of show you the power of this. So in my case, I've got some video files, and in the real world, this might be an actual live feed of video coming through. So you can see, most of the time it's just sitting there looking at a blank road, but every once in a while a car comes through. So in this simple model, what I want to do is I want to take this this video coming off of my camera or my cameras, and I want to extract or just give me the interesting parts. And in this case, the interesting parts are cars that are coming through the frame, because that's what the model's looking for. So what's happening is this. So what I'm doing is to simulate this, I've taken about 22 minutes of video. So each one of those 10, 11 files is approximately 2 minutes in length. And as you can see in the upper left, that's basically showing you every second it's taking a frame from that video and it's showing you the other. So there's nothing interesting I care about in this particular model, just a blank road. As you can see on the right, it's quickly going through that 22 minutes of video, finding what it was supposed to find, which in this case is a simple example of finding cars. Now, a couple of things I want to make sure and why I'm explaining this and the power of this. So this is running live. It's literally going through one second at a time through 22 minutes of video. So in about 90 seconds total, it's going to take about 1,300 or so frames and discern what's a car, what's not a car, and land those into Azure. And in this case, it may be that I want to land just the cars in Azure because I don't care about the rest of it, right? So again, I'm pre-processing the data and I'm getting rid of all the noise, all the junk, if you will. I'm not going to waste my time and my bandwidth for that. So hopefully you get the picture. And also notice the other thing is this particular machine learning model is making use of that FPGA. And so quick back of the napkin math tells me I'm clipping at about 15 or so, 16 or so frames per second, if because it takes about 90 seconds to go through the 22 minutes. And the FPGA, if I were to use that same model and not make use of FPGA, we're finding it's about 20 or 25 times better or faster or more efficient using the FPGA. So again, it's done, and notice it cleaned itself up. The local share, essentially, it's the container is told, hey, I want to, once I'm done with the video file or the stream that's coming in, I groom out the rest, and then I parse out what's interesting over or not interesting, what's over on the left, to maybe what is interesting over here on the right for a simple object detection walkthrough. Again, a very I'll call it basic walkthrough of how this goes, but again, very relevant to real world and even more complex scenarios. The magic happens within whatever you're looking for in the inferencing that you're doing there and why you're doing that. And once I have this in place, it's not very hard to then make use of the rest of Azure, right? So again, hey, how about I use logic apps to notify somebody if something interesting, the anomaly I'm looking for is happening, that type of thing. Those are the types of use cases we're seeing people use this for. Okay, and now I'm trying to get back to my environment here. Hang on one second. Let's stop presenting for a second here. Go back here. All right. So, and that's it. So, any questions with that? Feel free. I'll hang out in the chat for a little bit longer here. But again, I just wanted to give you more of a basic walkthrough, a simpler walkthrough of what DataBox Edge has to offer. And hopefully that was helpful. If you have any questions, please feel free to email me, or again, I'll hang out online here and see if there's any questions. As always, the next call will be in 2 weeks from today. And so 2 weeks from today will be on the 11th of October. We'll meet again at 11 a.m. Central, and I will update with the focus area and the topic at the AKA link when I have it locked down. Thanks.